going to go ahead and go to section 2.4, surveys and cardinal numbers. We've talked about cardinal numbers before. Cardinal numbers are just the number of elements in a set. And surveys are where we ask questions of people generally. I mean, it may not be that we're asking questions of people, but we're just collecting information some way, somehow. One way is to ask people questions like, where do you study on campus, is an example we're going to see in this slideshow. And we analyze the results to break it down so we can, get whatever information we're trying to find. For example, in our example today, we say, do you study at the student union? Do you study at the library? We use that information to determine how many study at both and how many study at neither. One of the things that one of the tools that we'll use when we're dealing with cardinalities is called the cardinal number formula, which relates the number of elements in the union of a set of two sets to the number of elements in each of the set. Let's see. So in both classes, I was able to show you this example where we find the cardinality of the set A intersect B by reading the cardinalities off of the Venn diagram here. So you can see the numbers 6, 4, 2, and 1. These represent how many elements fall into each of the regions of the Venn diagram. So for example, in set A, which has two regions, it's broken up into two regions, one with 6 elements and one with 4, we know that set A has 10 elements. So if you're asked to find the cardinality of set A intersect B, then we're just looking at the overlap between A and B. Remember, upside down U means intersection, which is overlap, what they have in common. So the number of elements in A intersect B is 4. If you're asked to find A union B, right, the right side up U means union. That means put everything together in the two sets. So that would mean we need to look at 6, 4, and 2. And so the number of elements in A union B is 12. Okay, so one type of problem that you're going to have in my math lab, we give you information about the sets, and we ask you to figure out how many are in each region. So these are unknowns, W, X, Y, and Z. We don't know how many are in each of these regions. And remember, I mentioned in class that what you want to do is you want to look for one piece of information that tells you about a single region. Okay, so for example, N of A equals 21 does not tell you about a single region. That tells you about region X and region Y. So that's not going to be the information you're going to start with. You're going to try to find one of these facts that relates to a single region. So, for example, the number of elements in A intersect B. Intersections are often a good place to start, because it narrows it down to a particular region. So A intersect B is referring to this little football-shaped region in between, or I should say in the overlap of A and B. So we know that there are 14 elements, so Y is equal to 14. Once you've used that fact, cross it off and go on to some other facts and see if now those facts are telling you about a single region. Here's what I mean by that. We just figured out that Y has 14 elements. The set A is comprised of X and Y elements. So there's only one value missing from here. So we know that there are 21 elements split between X and Y, and if we know that Y is 14, that must mean that X is 21 minus 14, which is 7 elements. So we can now use the cardinality of A being 21 to get the region X. You can also use the cardinality of B being 20 in a similar way. Since Y is 14 and B comprises both regions Y and Z, then that means that 20 minus 14 must be Z. 20 minus 14 is 6, so there must be 6 elements in Z. Okay? All right, and then now we have X is 7, Y is 14, Z is 6. The only thing we're missing is W. Let's cross off these two that we just used, and then we're going to look at the only other clue that we have left here, which is that the number of elements in B prime equals 37. So again, we have 14 in the intersection. We had 7 in the part of A that is not overlapping B. We have 6 in the part of B that's not overlapping A. What is B complement describing? B complement is everything outside of B, so that's going to include X and W. And we know that X has 7, so W must be 37 minus those 7 we've already accounted for, which equals 30. So we can say W is 30, and now we have all of the unknown pieces. So this is basically what you're going to be doing with survey questions, except they're going to be applications. Okay, next we're going to talk about the cardinal number formula. We're going to look at the first example we saw today, to understand what the cardinal number formula is saying. So the cardinal number formula gives you a relationship between the number of elements in the union, the number of elements in each of the individual sets, and the number of elements in the intersection. And the way that it works is that if you take the number of elements in the union, for example here, A union B has 6 plus 4 plus 2 is 12 elements in it. We already found that before. The number in just A, you might think is, well, I shouldn't say just A. The number in the set A, you might think is 6 looking at this, but actually remember A represents the circle. So 6 plus 4 is 10 elements in A. And then in B, 4 plus 2 is 6. If we were to just add the number in A, 10, plus the number in B, 6, that would add up to 16, which is too much. Why? Because we've counted this 4 as both part of set A and part of set B. So if we add these together, we're overcounting the 4. Now the 4 is just the intersection of A and B, or it's the number of elements rather in the intersection of A and B. So if we subtract off that 4 from 16, notice we get 12. We had counted the 4 twice, now we're taking off that extra count. So this is the cardinal number formula, and on the next slide we're going to see how we can apply it. I'm just checking the comments now. No questions so far. Okay. All right, so you will have problems like this. It says find the number of elements in A. If the number in A union B is 78, the number in A intersect B is 21, and the number in B is 36. All right, so there are two basic approaches to this problem. One is to write out the cardinal number formula. The number of elements in A union B equals the number of elements in A plus the number of elements in B minus the number in the intersection. All right, then fill in what you know. We know that the number in A union B is 78. We are looking for the number in A. The number in B we were given is 36. And the number in A intersect B is 21. So we have 78 equals n of A plus 36 minus 21 is going to be 15. So if 78 is n of A, the number in A, plus 15, then we're going to subtract 15 to figure out how many are in the set A. 78 minus 15 is 63. So that's one way. If you have the cardinal number formula memorized, that's one way to solve that exercise. Another way would be to actually draw a Venn diagram. So let's see what would happen there. So if I draw a Venn diagram with sets A and B, they're telling me that A intersect B has 21 elements in it. They tell me that the number in B, all of B, is 36. So if 21 of those are in the intersection, then 36 minus 21, or 15, is going to be in just B. And then the number in the whole union is 78. So that would mean all of this together is 78. So if I take away the 36 that are in B, then we're going to get 42 that are just in A. All right, so, and that's what we were looking for. Oh no, I take that back. Bad teacher. That's not just in A. That's, let me number these regions like we did in class so I can be more accurate here. All right. 1, if that's region 1, and this is region 2, and this is region 3, and this is region 4, then what I just found is the number that are in region 1, just in A, not overlapping with B. So if I want to know how many are in the total set A, I need to add the number in region 1 plus the number in region 2. So that would be 42 plus 21, which would be 63, like we found before. So obviously if you memorize the cardinal number formula, it's a lot faster in this situation when they give you the union, the intersection in one of the sets to find the number in the third set. I mean in the second set. Okay, let me check my chat again here. Okay, no more comments. So let's keep going. All right, so a college survey was taken. This is an example of a survey problem. A college survey was taken to determine where students study. Of 121 students surveyed, 77 studied in the library, 64 studied in the student union, and 28 studied in both the library and the student union. Okay, so right here I have set up your typical two-set Venn diagram. A is the circle on the left, B is the circle on the right. Let's say that A is the students who responded that they study in the library, and B represents the student union. Okay, then we have 4 regions here, 1, 2, 3, and 4, and then we have U. U is going to represent all of the students surveyed. So you'll notice that the first thing they tell us is that 121 students are surveyed. That's the cardinality of the universal set U. That's everybody under consideration. Okay, now the next thing they tell us is that 77 studied in the library. So if A is the set of all students who studied in the library, which by the way includes both region 1 and region 2, then what they just told us is the cardinality of A is 77. Okay, so that's the total of the number in region 1 plus the number in region 2. All right, and then let's see what else they gave us. 64 studied in the student union. Okay, so the number in B, the number who studied in the student union, is going to be 64. That's the total of region 2 plus region 3, right? Because set B includes both. And then lastly, they tell us that 28 studied in both the library and the student union. Remember the word "and" is associated with intersection? So this is the overlap between the two sets. So this is the number of elements in A intersect B. they're telling us is 28, and that is just region 2. So when we look through the facts that they've given us, we want to focus in on the one that tells us about a single region. Remember, the number in U was telling us about the number in 1 plus the number in region 2 plus the number in region 3 plus the number in region 4, by the way. These two are each telling us about a sum of 2 regions. So the only one that's telling us about a single region is the number in the intersection A intersect B. So let's go ahead and use that fact. I'm going to label the cardinality of region 2 on my Venn diagram. So there's 28. I'm going to cross off this because I've used it. And now I'm going to find a different fact. And for example, the number in B now, there's only one region left that I don't know in B. So if I know the total in B is 64, then in region 3 I must have 64 minus the 28 that was already accounted for. And let's see, 64 minus 30 would be 24, so that's going to be 26 in region 3. All right, and now we're done with this fact about region B, or set B. Now let's talk about set A. Set A is regions 1 and 2. It has 77 elements altogether. We've already accounted for 28 of them. So 77 minus 28, well, let's see, 77 minus 27 would be 50. So it's one less than that, so it's going to be 49. So there are 49 in region 1. So we've used that fact. And next we want to use the only remaining fact, which is that the total in the universal set is 121. Now the universal set includes 1 and 2 and 3 and 4. So it's going to be the 77 that we had from set A, which was regions 1 and 2. Plus we have region 3 was 26, plus whatever's in region 4, which we don't know, right? But 77 plus 26 is going to be, what, 103? So altogether, these three have 103, plus however many are in region 4 has to add up to 121. So 121 equals 103 plus however many are in region 4. So that means that the number in region 4, Roman numeral 4, is going to be 121 minus 103, which would be what, 18? So region 4 contains 18 elements. So let's say that I asked you how many students studied in neither the student union nor the library. How many students studied in neither the student union nor the library? Okay, so you would say, okay, that means they're not in A and they're not in B, so they're only out in region 4, so the answer would be 18. And we could ask other questions as well, like, for example, how many students studied in the library but not the student union would be 49, region 1. Okay, so this next example, we're going, let me check my comments. Tanya asked, can't you just add 49, 28, and 26? Yes, that would work as well. Okay, but now we're going to move on to this survey question, which involves 3 sets. Suppose that a group of 140 people were questioned about particular sports that they watch regularly, and the following information was produced. 93 like football, 70 like baseball, 40 like hockey, 40 like football and baseball, 25 like baseball and hockey, 28 like football and hockey, and 20 like all three. How many people like only football, and how many people don't like any of the sports? Okay, so what we're going to do is we're going to label the set of people that like football F, capital F. So the number who like football, you should jot down on your notes. And by the way, it's a good idea to take notes just like you do in class. The number who like football is 93. The number who like capital B for baseball is 70. And the number who like hockey is 40. So what is this number 40 over here that like football and baseball? So remember, the word "and" has to do with intersections, the overlap, what's in both. So in this case, we're having football and baseball, F and B. So what they're telling us is the number in the region football and baseball, the overlap, the intersection, is 40. The next one, 25 like baseball and hockey, so they're telling us the number who like baseball and hockey is 25. On the next one, they're telling us the number who like football and hockey is 28. And then the number who like all three, so it's the intersection of football and hockey and baseball, is 20. We're going to use these facts in order to build a Venn diagram, and then we're going to use our Venn diagram to answer the question, how many people